actually the first presenter. I just figured I'd just introduce everybody. And Josh, Sanji, Joe, John, Elliot, we're going to be your presenters. The first person up is actually Josh, and he's going to discuss wireless LANs.
Hey guys, I'm Josh, and I'll be talking about wireless LANs. So recently, wireless LANs have become more popular. They're used a lot in offices, and campuses, and airports, and coffee shops. So they're very useful, and they're very popular because they allow people to connect pretty much anywhere there's wireless connection. They connect their smartphones, laptops, pretty much anything they want. And also, it uses the standard. The LAN standard is 802.11, which is also called Wi-Fi. So the most popular mode that the clients like to use is the infrastructure mode, right there. And yeah, so they have two modes: the infrastructure and the ad hoc modes. First, I'm going to talk about the infrastructure mode, which it connects the clients, which the clients are the smartphones, laptops, pretty much anything like you can use a printer, and connects it to what is called an access point, which an access point is also called a base station, which is pretty much it's connected wired to connected to a wired network, which then connects it to the internet. So they use the clients or use the access point to connect to the internet. They also have something called a distribution system, which is many access points connected, and which it extends the 802.11 network, so it makes it extended. And so the clients, they send packets back and forth. So they receive packets, and they also send out packets through the access point. And so there is the next mode is called the ad hoc mode, which is it doesn't have access points. It's pretty much a bunch of computers connected to each other, and it doesn't have internet, so it's not connected to a network at all. It's just pretty much computers that they send frames back and forth to each other, and it's not very popular because it doesn't have internet. People need internet a lot to pretty much get anything done with their computers. So then we're going to have Sachi talking about protocol stack physical layer.
Alright, so this protocol stack physical layer, it mainly goes over the 802.11 layer again, because so mainly the physical layer, it corresponds to the OSI physical layer, where the data link layer, it has 802 protocol split into 2 or more sublayers, so there's multiple parts to it. There's also a logical link control sublayer that hides the differences between these protocols. And there's multiple transmission techniques that have been added over the years, ever since 1997. 802.11b is actually the first one to come up. That became popularized because 802.11a is far more advanced, as you can see, at 54 megabits per second and a 5 gigahertz band. And then it goes B, and then there's the 802.11g, which speeds up to 54 megabits per second, 5 gigahertz band again. And the 802.11n, which is the most advanced and the highest they've gone so far, where the speeds are up to 100 megabits per second in a 2.4 gigahertz band. Each technique is able to send a MAC frame over the air. All these methods, they basically define the multiple rates, so that if wired signal is weak, a lower rate can be used. And so another little tidbit could be that yes, the 802.11a in 1999 uses orthogonal frequency division multiplexing, which is different from what 802.11b used, because this is more advanced because it resists wireless signal degradations, and 802.11b is also over a spread spectrum, so that it's more efficient. And now Jason will take care of broadband wireless.
Also known as WiMAX. Basically, one of the biggest problems is the cost of actually laying fiber out. We all know Google Fiber is coming to Charlotte, and if you notice, they are only doing it by participation. And that basically means that they've asked you to sign up your neighborhood, and only those people that have the most, those neighborhoods that have the most requests, they're actually going to lay the fiber down there because it's not cost effective. WiMAX, on the other hand, is a little bit more cost effective. It's not going to require the line of sight links. By using the OFMD frequencies, it can go from the 2 gigahertz to the 10 gigahertz frames. And the structure is a lot like the 802 networks, but the sublayers are actually broken out a little bit different. There are 3 sublayers, and the bottom layer is basically going to deal with all of the privacy and security and manages the encryption and decryption and as well as the key management. Now, between 802.11 and 802.16, which is what the WiMAX standard is called, it's basically like you take 802.11 and you kind of add 3G. 802.16 is a lot like LTE is today. LTE is actually coming up to the spectrum of 802.16. So the biggest thing is right now there's a kind of like a fight. Which one's going to basically win the standard, because they are coming in together. The protocol stack for the WiMAX is basically you're going to have the upper layer that defines the IP, and then the service specific, how it basically is going to talk to the IP from the MAC layer, and then you have the security layer. The security layer is pretty much laid out in the sense of they're going to use, instead of using a PA2, they actually use X509 certificates. So that way everything is actually going to be encrypted via AES or DES with a cipher block. And that's the important thing right there is when you sign up for WiMAX, if it comes through, again, we don't know if LTE is going to, if LTE will beat it because they actually work in each other's spectrum. Your encryption is actually going to be, you're going to be given a certificate in order to basically encrypt all of your data and everything. The MAC sublayer, there are basically 4 services defined. One is the constant bitrate service, and basically constant bitrate is, think uncompressed voice. All of your voice over IP applications are basically on a constant bitrate. The real-time variable rate is where you get your streaming music and your software applications. And the non-real-time variable service is your large file transfers. The last service is basically your best effort. And that's basically what it sounds like. Anything else that's not these items, it's going to be the best effort. Okay? And the next thing we're going to talk about is Elliot's going to discuss Bluetooth.
All right. So what exactly is Bluetooth? Bluetooth is a wireless standard for connecting computing devices or accessories to communication devices. And this is accomplished through a short-range, low-powered wireless radios. The basic unit in Bluetooth is the PicoNet, a short-range network which consists of a master node and 7 slave nodes. The combination of several PicoNets being connected through a bridge node is called a scatternet. Bluetooth currently has 25 application uses that it supports, which are called profiles. These give Bluetooth the ability to communicate with audio and video, allow hands-free communication, to stream audio and video, connecting to keyboard and mouse, and many more uses. It's important to note that Bluetooth has its own architecture model. It's called the Bluetooth protocol stack, and it consists of a physical radio layer, a baseband layer, which can be thought of as a MAC sublayer, a layer for link control, which handles power management and pairing, and top application layers, which contain the 25 profiles that I mentioned earlier. And next we're going to have Jonathan talking about RFID.
Yeah, I think
We'll have a video.
video.
Okay.